the exam. Okay, so the question is, for the given SFD shear force diagram, draw the load diagram and bending moment diagram. Assume no couple acting on the beam, right? So this is a very simple numerical. So first thing what we have to do is we have to reproduce the diagram on your answer sheets as it is, and then first we will try to draw the load diagram based on the shear force diagram, right? So for doing that, I will just extend these lines. Okay. All right. Now let us start from the left hand end of the beam. So before I begin, I will name the salient points here. So I'll call this as point A, then this will be B, this is C, and this will be D. Okay, I have 4 points on the beam and I have named these points. Now if you see at point number A, the shear force is increasing from 0 to 35 kilonewton, right? It is positive shear force, so it is upward. So before I begin, first I will draw a horizontal line which is representing the beam now, right? So these are points A, B, C, D. Name them again here. A, this will be B, this will be C, and this is D. So at point A, I have an upward force and the magnitude is equal to 35 kilonewton. So what I will do is I will draw a arrow like this at point A, right? So since it is upward, so my assumption is that this will be the reaction at this point. So I'll call this as RA, and that magnitude is 35 kilonewton. Alright. Then again come back to shear force diagram. Between A and B, there is no change in the shear force. It's a horizontal line. Here also it is 35. Here also it is 35 kilonewton. So it is a horizontal line like this. So there will be no load between A and B. If it were to be inclined, then it is UDL. But now here it is not given anything like this. So there is no load. Again at point B, if you see, the shear force is decreasing from 35 kilonewton to 0. That means there is a downward force acting at point B, and the magnitude of that force is equal to 35 kilonewton. So I will show this as a point load, right? And the magnitude of this is 35 kilonewton. Now between B and C again, I do not have any load. That is why the shear force is constant. It is 0. It does not change. At point C, there is again shear force uh, which is decreasing from 0 to 35. This is the negative side, minus 35, right? So that means it is a downward force, and the magnitude of that force is also 35 kilonewton. So I will put one more arrow here and the magnitude of this is 35 kilo Newton. Then between C and D there is no load. The shear force is constant, minus 35 here, and here also it is minus 35. At D the shear force is increasing from minus 35 to 0. So that means it is an upward force here, right? Minus 35 plus 35 will become 0. So there is a upward force here, and the magnitude of that is 35 kilonewton. So I will show a upward arrow like this. Now since this is the end of the beam, so this will be the reaction. RD is equal to 35 kilo Newton. Okay, so this is the load diagram for the given SFD. Okay, now after drawing the load diagram, I have to draw the bending moment diagram. Okay, so for drawing the bending moment diagram, I have to first find the bending moments. So let me just calculate the bending moments here. Bm at A is equal to Bm at D is equal to 0. Reason is end support. Whenever you have a end support and there is no couple acting on the end, or if it is a free hand in a cantilever or a simply supported beam or a overhanging beam, then the bending moment at that point will be 0. Only condition when you get bending moment at the support or the end is when you have a couple there. Okay, let me come to point B. BMB is equal to, at this point you can either take left side or right side, bending moment from left side or right side, we get same answer. What I have suggested is use the side where you have less forces. Now left side there is only one force, so I will use this. This is left side upward force, and this is making a clockwise couple. So left side clockwise is positive. So Bm at B is equal to Ra, that is 35, into the perpendicular distance is 2 meter. 2, so that will be 70 kilonewton meter. Then I have to come to point C, and at point C, again if you see here, it is on the right side I have only one force, left side you have two forces. So take the right side, it's an upward force here. This is making counterclockwise couple. Right side counterclockwise is positive. So BMC is equal to positive 35 into 2, and that is equal to again 70 kilonewton meter, right? So I have done with all the calculation of bending moment that is required. Now I can draw the bending moment diagram. So I'll just extend this a bit. That's fine. Now first I will draw a horizontal line. You have to see the values of the bending moment. All are positive values. It is varying between 0 and 70. So I have drawn a horizontal line. Let us say at B it is 70 in some scale. Let us say this is 70 kilonewton meter, and C also it is 70. So we just have to draw a trapezium shape BMD like this, right? Now let us name all the values. This is 0 and this is 70 kilonewton meter. Again this is 0 and this is your BMD, right? So this is the solution for this. Any questions in this?